So maybe we should go back to geometry and figure out something from there. So let me try to do that quickly. So, how to measure the angle between two planes? What do we know about these two planes? Well, we know there is a point f of t and a point f of t plus delta t. And at both times, we make the osculating planes, and then we want to measure the angle between them. And the way we measured angle between planes was by normal vectors, right? Because it's easy to measure angle between vectors rather than planes. So we take a plane made by v of t and a of t. And what's the normal to that? How to make a normal vector to that plane? I know, it's slow Monday.
Just B cross A.
B cross A, yes. So make the cross product. That will be a vector perpendicular to the first osculating plane. And then we have v of t plus delta t and a of t plus delta t. And I make a vector perpendicular to that plane. And then I have to look at these two vectors and find the angle between those two. How do we find the angle between two vectors? Cosine law. Do you remember how we did it for the formula for the curvature?
We use sine.
Remember that we had a problem using cosine, right? So I just don't have time now to go into and see where exactly we have that problem. But instead of cosine of the angle and using dot product, we will use what? Sine, and sine is a part of, well, now in 3D it's vector product. And we have to take this vector, we have to take that vector, then cross product of these two is going to be magnitude of that times magnitude of that times sine of angle between them. So if I divide that, well, of course, magnitude of that cross product, if I divide that magnitude by magnitude of the vector v of t cross a of t, and also magnitude of v of t plus delta t cross a of t plus delta t, that's going to be sine of the angle. And of course I have to take sine inverse of all that. And that is finally my angle between the planes that I have to relate to what? To the distance traveled. Now, we'll have to take that ratio and take limit, right, of the whole thing. And how did we do it last time? Well, the idea was to linearize both top and bottom. Because if you just substitute delta t equals 0, you will get 0 over 0. The whole thing will be indefinite. So last time what I did was I linearized the denominator, and that was easy. Linearization of denominator is the speed at the time t times delta t. Well, remember, I'm linearizing with respect to delta t because that's what goes to 0 under the limit. So denominator is easier to linearize. The real question is how to linearize numerator. And what I did last time is I took the whole numerator, treated it as a function of delta t, a huge function. And I know the value of that function at delta t equals 0 is 0. And I'm looking for the linear Taylor series term. So I took the derivative of the whole thing with respect to delta t, and I had to evaluate that derivative at 0. Well, that's a lot of work. If you imagine taking derivative of sine inverse, and then by the chain rule, derivative of the fraction, and that fraction contains magnitude of a vector, which is a vector product of two vector products, well, that's a lot of work.